All right, chapter 6 test. First thing you were supposed to do was to graph the curves in the first quadrant. So, first quadrant, e to the x, or x over 4, always goes through 1. If you drop it by 1, it's going to go through there. So it's going to be some kind of curve that does like this. This is a parabola. This is just a number, a constant. 2.7 minus 1 is 1.7. 1 something, 1 8, something like that. So this is just a parabola that's got a 1/16, some shoved 4 over, whatever, but it's upside down, so it's an upside down parabola. Now, if you don't believe me, I typed those into my calculator here, and then you can see that they're typed in. And then I'll push graph, and I'm in Zoom 4 to see this. You might need to go Zoom 6, but it looks like they cross at 0, 0. Let's check that out. If I put 0 in here, 0 divided by 4 is 0. E to the 0 is 1. 1 minus 1 is 0. And this one, if I put in 0, I get 4 minus 4 squared, 16. 16 divided by 16 is 1. 1 minus 1 is 0 times anything is 0. So they go through 0, 0. And it looks like they go through about 4 something. So I'm going to put some units on here, 4, and it looks like it's up about almost 2-ish, somewhere around in there. So there's that. So let's check and see what 4 does. 4 divided by 4 is 1. E to the 1 is E. E minus 1 is E minus 1. So one graph I get from this one, I get E minus 1. Suspicious. If I put 4 in here, 4 minus 4 is 0. 16 divided by 0 is 0. 1 minus 0 is 1. 1 times E minus 1 is E minus 1. So it does go through 4 E minus 1. I like to see units on your graph. Now, some of you had a hard time telling which one was the top one and which one was the bottom one. If you're struggling with that, I mean, on this calculator, it color codes it, but you could also just turn one of them off by pressing enter on the equal sign and then graph. There is the one that is graphing, the e to the x divided by 4 minus 1. So the bottom one is this one. The top one is in this section is that one, and we're supposed to do the area that's enclosed. So that would be the integral. And if we just go vertically, which is the easiest way to do it on this one, and trying to go sideways, you'd have to have these all solved for x, and I would not want to do that. So we're going to go vertical slices, which would be dx. And so x is going to go from 0 to 4. And the top equation is simply e minus 1. Well, maybe not so simply, but 1 minus x minus 4 squared over 16. That's the top curve. Minus the bottom curve, which is e to the x over 4 minus 1. But I need to put that in parentheses because it's all subtracted. If I don't do that, I'll have the wrong sign on that 1. And all of this is dx. So the setup is here, and that's all I asked you to do. Didn't ask you to solve the integral. Okay. Here's a much simpler curve. It's a parabola, upside down, up 4. 1, 2, 3, 4. A parabola with a 1 in front of the x squared goes over 1, down 1, since it's negative, both ways. And then if you go over 2, it's down 4. So it hits at 2, intersects at minus 2, and has a height of 4. And I really want you to put units on your graph. And some people had all kinds of weird things here. It said rotated the area around the x-axis. This is the x-axis. If I rotate it around that, it's going to come down here. No holes, nothing complicated. If I do disk method, I'll do them both here. Disk method, I would slice it perpendicular to the axis. The thickness of the disk would be dx because its thickness is in the x direction. So it'd be dx, and I can do all of it from -2 to 2, or I can go from 0 to 2 and double it. I'll just do all of it, -2 to 2. Some people did that. And this is going to go around and make a circle, which is going to have an area of pi r squared, a volume of pi r squared dx. So I'd have to replace the r squared. R in this case is y, and y is 4 minus x squared. So this would become the integral from -2 to 2 pi r squared, which is going to be 4 minus x squared. So it's going to become pi integral from -2 to 2. This squared is going to be 16 minus 8x squared plus x to the 4th. And when I integrate that, it's going to be pi 16x minus 8x to the 3rd over 3 plus x to the 5 over 5, evaluated from -2 to 2, or double this and go from 0 to 2. And many of you had trouble plugging in the numbers on this. Let's see what happened. So if I go to second quit, go to them here, and type in 16. Actually, the easy way to do this, I'll show you this just so you can do it. Enter. Come down here. I'm going to type in what I got to put these numbers into. 16x minus 8x to the 3rd divided by 3 plus x to the 5th divided by 5. So I just want to plug 2 and -2 into these. Now I can go to value. There's a bunch of ways I can do that. One way, I'll do it this way. 1 second. I'll go to vars, y variables, y3. Oop, I don't want to put it there. Delete. This is the thing. So I'm going to go to my home screen and go vars, y vars, function 3. Put in 2. And when I put 2 in, I get 17.0666 repeating. I can change that to a fraction. Math, enter. That's 256 fifteenths minus, now I got to put in -2. So instead of 2, I'm going to put in a -2. And I get the negative of the same thing. So I get -256 over 15. Minus a minus is plus, so I'm going to get pi times 2 of those, which is 512 fifteenths. Okay, if I did it with the shell method, I'll just set this one up. Then I would be integrating. The thickness of the shell would be dy. And so then I would have to go the thickness dy times 2 pi. The radius would be y. That's how far up it is to this. And the height would be x times 2. X times 2. And since it's y, I'd have to change the x. And so I'd have to solve for the x in this, which would be y equals 4 minus x squared. So I'd add x squared and subtract y. And so x would be the square root of 4 minus y. And I'd have to integrate that. Do a u substitution for 4 minus y. That's the first page.